Okay, so our first lesson in Chapter 8 is on equations in two variables. And we're going to learn to solve equations in two variables over given domains of the variable. So we'll learn what a domain is. So we've talked about one variable equations. 2x minus 3 equals 7. That's a typical equation that we've learned to solve. 1 minus y equals 9. X squared plus 5x plus 4 equals 4. This is a equals 0. This is a quadratic equation. I totally forgot what it's called. A quadratic equation, which we've learned how to solve by factoring. Okay, but these are all considered one variable equations because there's only one variable. In each case, that's here, there's just x, here y, here another x. We're going to talk about two variable equations where we have two completely different variables within the equation. So here we have 4x plus 3y equals 10. This is a type of equation we're going to be looking at in this chapter. X times y equals 6, two different variables, and x squared plus y squared equals 4, again, two different variables. So we're going to be looking at this type, which are called linear equations. So the solutions to equations in one variable are numbers. The solutions to equations in two variables are pairs of numbers. For example, the pair of numbers x equals 1 and y equals 2 is a solution of the equation 4x plus 3y equals 10, because if I plug in 1 for x, I get 4 times 1. And if I plug in 2 for y, I get 3 times 2. And 4 plus 6 is equal to 10. Okay, so that solution is the ordered pair of 1, 2. The solution x equals 1 and y equals 2 can be written as 1, 2 with the x value written first. Okay, because that's how we write an ordered pair, x first, y second. A pair of numbers such as 1, 2, for which the order of the numbers is important, is called an ordered pair. Now, this is something we've talked about in 5th and 6th and in 7th grade, what ordered pairs are. Ordered pairs are a pair of numbers. They're in a specific order, and they must be written in parentheses. If they're not in parentheses, then they're not an ordered pair. They're just two numbers. Okay, so to indicate that something is an ordered pair, they're in parentheses. The x value is first, the y value is second, and they're separated by a comma. Okay, so let's look at example 1. It says, state whether each ordered pair of numbers is a solution of 4x plus 3y equals 10. Now, this is the same equation we just used up here, and we said that 1, 2 was a solution. But the thing about linear equations is there's always more than one solution. Well, not always. If there's one solution, then there's more than one. If there's no solution, there's no solution. Okay, so we're going to look to see whether these ordered pairs are solutions of this equation. And we're going to do that by plugging them in. So here we have 4 times 4, because my x is equal to 4, plus 3 times negative 2. So I have 16 plus negative 6, which is equal to 10. So yes, 4 negative 2 is a solution to this equation. I'm going to do the same thing here. So 4 times negative 2 plus 3 times 6. 4 times negative 2 is negative 8. 3 times 6 is 18. And when I add those, I get 10. So yes, that is also a solution. Here I have fractions. And it's automatically, you want to say, well, fractions can't work. Well, let's try it out. So I have 4 over 1 times 3 over 2 plus 4 over 3 times 3 over 1. So here, that's a 1, that's a 2, and I get 6. 3's cancel out, and I get 4, and that equals 10. So yes, even fractions will work. If we look at the last one here, I have to fix my lead. If we look at the last one, I have 4 times 3 plus 3 times negative 1. That's 12. Minus 3 is 9. So no, this one is not a solution. Okay, but notice that I have 1, 2, 3, 4 solutions for this equation. There's actually an infinite number of solutions for this particular equation. Now let's look at this next one. Solve x plus 1 times y equals 3 if x and y are whole numbers. Okay, so this one is not a linear equation. Okay, but it is an equation in two variables, and I'm looking to see what whole numbers I can find for x and y that make this true. And I'm going to start by solving for y. So I'm going to divide both sides by x plus 1, just to make it easier. So y is equal to 3 divided by x plus 1. I lost my 1 there. Okay. So I need to come up with a number I can plug in for x that will give me a whole number for y. And remember, whole numbers are not negative. They're integers that are positive. Okay. So let's see. If I plug in a 2 for x, let me do a little chart here. If I plug in a 2 for x, that's going to give me 3 over 3, which is going to give me 1. If I plug in, let's say, a -1, but negative ones aren't whole numbers, are they? So I can't plug in a negative. How about if I plug in 0 for x? That's going to give me 1. So 3 over 1 is just 3. And how about if I plug in, is there anything else I can plug in? Let's try 1. 1 plus 1 is 2. That would give me 3 halves. But 3 halves is not a whole number. So it looks like there's only 2 solutions for this. Okay, 2, 1, and 0, 3. I think those are my only 2 solutions for this particular problem. And because it's not linear, because I'm multiplying these, it's not a linear equation, there could be just two values. Whereas a linear equation, if there's one solution, there's an infinite number of solutions. All right, so let's look at example 3 now. Dawn spent $13 on pens and notebooks. The pens cost $2 each and the notebooks cost $3 each. How many of each did she buy? So I'm going to write an equation, and I'm going to, instead of using x and y, I'm going to use p for pens, and I'm going to use n for notebooks. So each pen costs $2. Each notebook costs 3. So if p is the number of pens, p times 2 gives me the total price for the pens. If n is the number of notebooks, then 3 times n gives me the total cost for the notebooks, and that should add up to 13. Now, before I start picking numbers, I need to think about this. I have to have a whole number for p and n because I can't buy part of a pen or part of a notebook, and I can't buy a negative pen or a negative notebook. So I'm looking for numbers that I can plug in that will make this true. So let's start with if I buy 1 pen, that would be $2. That means this has to become 11. 3 times something has to equal 11. So that's not going to work. If I buy 2 pens, this would be $4, which means this would have to become 9, which will work. So I can have 2 pens and 3 notebooks, okay, because that would be 4 and that would be 9, which equals 13. So I have, let's write that down, 2 pens and 3 notebooks. So that's one combination. What if I didn't buy any pens? Is there something I can multiply by 3 to get 13? No. And what if I didn't buy any notebooks? Is there something I can multiply by 2 to get 13? No. So zeros are not choices. What if I bought 3 pens? That would be 6. So this would have to become 7, and that won't work. If I bought 4 pens, this would be 8, which means this would need to be 5. So that's not going to work. So let's see, is there any other combination? What if I bought 5 pens? Let's do one more. 5 pens, that would be 10. So this could be 1, that would work. So 5 pens and 1 notebook, that would work. Because that would be 3 plus 10. So I think these are the only 2 combinations. But notice how it's kind of tricky. You're sitting there just plugging in numbers. We're going to learn an easier way to figure this out. All right, but for now, let's look at our try this. It says, is 5, -2 a solution of the equation x minus y equals 4? Well, the way we determine it is we plug it in. And remember, the first number is x, the second number is y. So I have 5 minus, y would be -1. Okay, and make sure you put that in parentheses. That becomes 5 plus 1 equals 4. So no, it's not a solution because it didn't work. If it works, it's a solution. And then number 2 says solve 3x plus 4y equals 12 if x and y are whole numbers. So this is a little bit different than the one we had before. Now, if I notice 3 is a factor of 12 and 4 is a factor of 12. Okay, so I'm going to go ahead and I'm going to make my little chart here. And I'm going to plug in 0 for x. So if I plug in 0 for x, I can multiply 4 times 3 to get 12. So there's one solution. And if I plug in 0 for y, cover that up, I can do 3 times 4, which will give me 12. So there's 2 solutions right there. So 0 is a legitimate solution. All right, so let's try 1. If I have a 3 here, this would have to add up to 9. That's not going to work. If I had a 2 here, that would be a 6. That's not going to work. If I had a 3 here, that would be a 9. That's not going to work. So having using numbers for 3 is not going to work. If I have Let's see, what else can I do? If I plug in numbers for here, if I plug in a 1 here, that's 4. This would have to be 8. 2, that's 8. This would have to be 4. So I think these are my only two solutions, are 0, 3, and 4, 0. I think those are the only two solutions that are going to work. And I'm trying to see if I can find... nope, that's it. The only two that'll work.